So last time we talked a bit about permutations. This was an ordered selection of objects. I think I wrote it last time. I called it a linear arrangement, but this really means the same thing. So basically, a permutation, you take, you've got a set of objects, and you choose some of them like in order. So, you know, if I take 1, 2, 3 is a permutation. Of the set, 1, 2, 3, and so is 3, 2, 1. Right? And these are kind of different permutations of 1, 2, 3. So yeah, so it's a linear arrangement. You arrange the elements from left to right. And we also saw that, you don't have to arrange all the elements. So if I took the set 1, 2, 3, 4, 1, 2, 3 is also a permutation of 1, 2, 3, 4. And so is 3, 2, 1. And those are different permutations because they have different orders. This time what we're going to look at is something called combinations. So a combination is an unordered selection of objects from a set. Okay. So, I mean, maybe I'll illustrate the difference with a kind of little example. So, suppose I'm picking a president, vice president, and treasurer from a group of 20 people. Or, so this is kind of one type of problem. Another thing is you could say, okay, suppose we're not picking a president, vice president, and treasurer. We're just picking a committee of 3 people. And those people don't have any special titles. They're just, everyone's equal in this committee. Okay, so this problem would be asking you, this is really a permutation problem. Because these people are sort of classified, president, vice president, treasurer. So there's sort of an ordering, or they're kind of distinguished, right? 3 different positions. Whereas this one would be a combination. Because the 3 people in the committee, there's no kind of ordering between them. So if I pick, Alice, Bob, and Fred on my committee, that's the same as picking Alice, Fred, and Bob, or Fred, Alice, and Bob. We consider all those things the same because, yeah. Whereas here, if it's president, vice president, treasurer, Alice, Bob, Fred, that's different than switching them, right? Is this distinction clear, or any questions about that? Okay, so let me give you some notation for this. So kind of like with permutations, I'm going to give you like 3 different notations for this. one of them, which are useful in different contexts. So one of them will be like the one from your textbook, one will be the one on your calculator, and then there's another one. So this is the other one. So the way you say this is n choose r. And it's the number of ways to select R objects from a set of size n. Okay. But in your textbook, they don't use this notation. They use a different notation, which is C bracket and R to mean the same thing. Apologies that things are so inconsistent, but yeah, you can't make all mathematicians use the same notation. And then your calculator uses NCR like this. But often when I write things on the board, I'll probably write it like this. Okay, so yeah, these all mean the same thing. Okay, let's solve this problem about a committee. Okay. So, well, here's one way to solve the problem without really understanding what you're doing, because you have a calculator, right? Well, and if you don't yet, I suggest getting one because it'll make your life a lot easier. I'm telling you, this is a combination problem. You got 20 people, you're selecting 3 of them. You can just put that in your calculator. So the answer is going to be 20C3, or in other words, 20 choose 3. And if you plug that in, hopefully it'll output 1140. Okay, so the calculator makes your life easier, but you should also understand where this 1140 comes from. So let me explain that. So where do I get this 1140? Well, okay, here's what I'm going to do to select my committee. First, I will, let's select the 3 people in an ordered way, right? So if we were solving this problem with the president, vice president, treasurer, how many ways would there be to select it? So you got 20 people, pick a president, then a vice president, then a treasurer. So something like, well, there's that many ways to pick the president, right? 20 people, 20 ways to pick. Once you pick the president, you've got 19 ways to pick the vice president and 18 ways to pick the treasurer. But this would be solving this problem, and we actually want to solve this problem. So we don't want to have, so here we've got a distinction between these 3 people that, one's the president, one's the vice president, one's the treasurer. Now imagine we remove that distinction and we just view them as 3 people in a committee. Well, each possible committee, let's say your committee is Alice, Bob, and Fred. Each possible committee got counted 6 times when I did this. 6 being 3 factorial. So each committee, so this counts each possible committee 3 factorial, which is 6, times. Because the committee, let's say Alice, Fred, and Bob, was counted with, or Alice, Bob, Fred. It was counted Alice, Fred, Bob, Bob, Alice, Fred, Bob, Fred, Alice, Fred, Alice, Bob, Fred, Bob, Alice. So for every like permutation of the letters A, F, and B, you know, this committee was counted that many times. So therefore, if I've overcounted the committees by a factor of 6, I should just divide by 6, and I'll get the right answer. So my answer should be 20 times 19 times 18 over 6, which hopefully works out to 1140. So that's how you could get the answer, even if you didn't know how to use this button on your calculator. Okay. Any questions about that? Yeah? Yeah, so it would be like, so if there were 4 people in the committee, you do 20 times 19 times 18 times 17, and then divide it by 4 factorial. Yeah. Good. Any other questions? Yeah. Because so if every committee gets counted 6 times, then the answer here is 6 times as big as it should be, not just plus 6 from what it should be, so, or plus 5 or whatever. So it's not just this committee that got counted 6 times, but now take a committee with 3 other people that also got counted 6 times. Another committee with 3 other people got counted 6 times. Everything got counted 6 times. Yeah. Yeah. Exactly, and that's a general principle that always will work. So yeah, so in general, if I want to find n choose R, well, so this is like picking a committee of R people from a set of n people. You can first take a permutation which will select these people in an ordered fashion, but then you realize that counts the committees too many times, and how many times does it count them? R factorial. Right? So in general, you should be dividing by R factorial. And last time we came up with the formula for this PNR thing, which was n factorial over n minus R factorial. So we can also say that this is n factorial over R factorial n minus R factorial. Okay, so this is a general formula for this. Okay, any questions about this? Yeah. You may come across some sort of like more theoretical questions. Like in theory, you could just have a question on your involving factorials or something. That would be kind of a lame question, but you are kind of responsible for knowing it. Any other questions? Yeah, I can see that this microphone is messing up. Sorry about that. Have been some problem with the recordings. But yeah, now it's just flashing red at me, so it's not working. Okay. Yeah, we won't bother with the microphone. Yeah, so in this classroom, the microphone doesn't work. In the other classroom where I teach this, the cameras don't work. So somehow if you put the audio of one with the video of the other, it might work. But yeah. Okay, so let's do another example. Let's say Alice has I think so. Yeah, because the only repeated letter is the A. So this is, you know, the positions for A's. And this is the rest. Yeah. Well, if you're to do it backwards, yeah, what you're saying makes sense. However, what you would do is, if we're doing this backwards, actually, if I do the x first, let's say, I've actually got 8 choices for the x. So it'd be like 8, and let's say I do the x, or let's say the e, the x, the b, and the k first. So 8 times 7 times 6 times 5 choices. Then I've got 4 things left, so I would do 4 choose 2 for the t, 2 choose 2 for the o's, which these don't look like the same number, right? But if you compute them, they will actually give you the same number. Yeah. But yeah, there's no special order you have to do things. If you can do it one way, you can do it another way. Yeah. Yeah. You could do the O's, then you could do the X, then you could do the E, then you could do the T's, then you could do the K. It doesn't really matter what order you do it. Yeah. Maybe let's not, I mean, there is kind of a general formula, but it'd be cumbersome for me to write it down because I have to say this letter's repeated this many times. It'll be a complicated formula. I'm not sure it'll help much, but basically what you should remember for this is the procedure, you know. Deal with the multiple, like the repeated letters, you know, and then maybe deal with the rest of the letters or vice versa. Any other questions? Okay, let's do variation of this. Let's suppose we're arranging the letters of academia. So again, the question is arrange the letters. How many such that all the A's are consecutive? Okay, so I want to find ways to arrange this so that somewhere in the word you have AAA all together. Okay. This might seem, oh yeah. Yeah, you're on the right track there. Yeah, you do want to think of this just as a sort of permutation question. Yeah, so, I mean, basically, this one might look trickier than the last one, but actually if you think of it in the right way, it's actually easier. Here's why. What if I just think of the A's, like if Yeah, so this is the ways to choose the position of A's. So in a permutation of this, and this is the number of ways after you choose the A's. When I say choose A's, I mean choose the position of the A's. After choosing A's, choose E and I. Yeah. Right, because once you put it in the A's, it can go E first, then I, or I first, then E. Two ways, 2 factorial ways. Yeah. They don't have to be in order. Oh yeah, so I'm not adding on top of the previous one. So these are just, the vowels are consecutive. The A's don't have to be. So it could be A, E, A, I, A, or something. Yeah. Yeah. They're all the same, yeah. 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 Yeah, so the vowel block is kind of treated as a letter, and then the consonants are treated as separate letters. Yeah. Cool. So these things, I mean, they do get complicated. Let me give you yet another variation. So what if I want to have no consecutive A's? Oh, yeah. Oh, in this case, we don't want consonants in between vowels. Yeah, so you want all the vowels consecutive, so that means that there's no, yeah, no problem. Any other questions? Okay. But actually,